Hello everybody and welcome to webinar What is coming in Ideostatica 21.1. I'm Martin, Operation Director at Ideostatica, and today I'm here with my colleagues, product engineers Lukáš and Ralph. Hello guys.
Hello Martin, hello everybody.
Hello.
Before we start, just let me mention that we are using GoToWebinar, and because there is a quite crowd here, we have put everybody to listen only mode. All of you can see on the right side a panel or ribbon of GoTo when you can set up your audio and also type in your questions. We will be answering them continuously during the webinar and of course at the end of the webinar. And today we will talk about a new version of Ideostatica, version 21.1. First, I will briefly mention or introduce highlights of the version. Then Ralph will tell us latest news about BIM links. Lukáš will show us what's new in concrete and Ralph in steel. And finally, I will tell you something about obsolete applications. So let's start with the highlights of the version. We have heard from our users, from you, that structural engineers need complete control over export from their fine element analysis software to Ideostatica. They want to know the status of their connections. And this is exactly what new Checkbot application does. Next, structural engineers are getting under a big pressure as they have to design a lighter and lighter members to save production cost. But to do that, to design slender columns, they are dealing with stability issues. And we can help them with Ideostatica member now. Until today, only a reinforced concrete expert could easily calculate openings and other details in our Ideostatica detail application. And now also bridge engineers and precast companies have these options because we added a pre-stressing feature into Ideostatica detail. And finally, connection browser, new library of connection designs which boost your input in Ideostatica connection. And moreover, you can also easily share your designs with colleagues and the other users. So I'm really looking forward to detailed explanation of new features from Lukáš and Ralph. And let's start with BIM links. Ralph, could you tell us more about new Ideostatica Checkbot?
Yes, certainly. And let me be presenter.
Mm-hmm.
Okay. There we go. And I think for this time, I think we'll turn the webcams off to make it a little bit easier for everybody as well.
Mm-hmm.
So we are here going to discuss the BIM links that's new in version 21.1. And first of all, we'd like to say a fond farewell to CodeCheck Manager and hello to the Checkbot. This brand new application for Ideostatica 21.1 gives you complete control over all of your members from your finite element analysis or from your BIM modeling solutions such as Revit and Tekla structures and advanced steel. It allows you to import your members and loads. Sometimes these are available, as you well know, from the same application. There is also a conversion table for materials and cross sections, which sort of learns as it goes when you import your models from these different solutions. It also has the ability to manage the loads and the combinations that come in from the finite element and some modeling solutions, which means that you can drastically cut down the load cases from quite a few to just the ones that you need to do your actual designs. So Code Check Manager is gone, as I've told you. Checkbot is a new solution for BIM links. This also covers the Idea Open Model method for importing data from other, let's say, non-supported or not developed by ourselves applications. And it can be used as an integrated method as well as a standalone. In the standalone mode, it allows you to import from the new Nemetschek SAF format, which is based on Microsoft Excel. And it indeed allows you to import data from SIA Engineer very easily. And again, it brings in the whole model from SIA Engineer through this new Excel SAF format. It is essentially your one-stop solution for BIM links. What we are striving for is a consistent approach to integrate these solutions that support an API. This will help both yourselves and, if I'm honest, it will help development, which means that we can react more efficiently with new versions of those applications that we integrate with, and it will improve your lives as well. The links that we support currently in version 21.1 are listed in the two tables on the slide at the moment. We unfortunately don't cover advanced design yet, but that's one of the ones that we're currently working on. And we don't cover MIDAS currently either. This is because MIDAS doesn't have a suitable API, so it needs a special approach. But as you can see, all the other major players in finite element analysis, modeling solutions for both steel and concrete are covered. If there are any specific questions about coverage, just ask a question in the panel later. And just back over to Martin.
So thank you, Ralph. Let me just sum up the benefits of new checkbots. As you see, there is a big flexibility and clarity improvement in this new application because we bring a new interface. The same for all our BIM links. We have just one workflow for all of our applications, for Ideostatica connection and for member. And for member, it's valid for both, for steel and concrete. And moreover, we have just one platform for all our external BIM links. So if you need to connect through our IOM, you can also use this checkbot functionalities. So once again, thank you to Ralph. And now let's check and see what is coming in concrete.
Thank you, Martin. I will take a presenter So
I don't think that
hope,
we see the right monitor. Now it's,
yeah,
yeah, now it's okay.
now it's fine. Okay, thank you. So hello everybody again. So I hope you are looking forward to concrete news, because a lot of efforts had been given to the development of the new features and improvements to this part. So let's go in. I would like to introduce a brand new feature that is implemented in Ideostatica detail, and it's pre-stressing in detail. The users will be able to design and assess pre and post tangent bonded structure in ultimate limit state. The tendon losses are currently entered manually using a reduced factor in combination. You can consider 15% for long-term losses. And also we are providing a big library of the materials for existing tendons. So you can find it there. Also for, let's say, more complex geometry of the tendons, you can import the layout from the DXF for complex geometry of the tendons itself. And what is really important, the tendon cannot be specified for trimmed end details. So you are getting more design option, and you can get more subtle structure right now. The other feature, or let's say improvement, is regarding speeding up of the calculation. You know that an increase in computational speed is always news that makes users happy. So sorry, the reinforcement ratio serves for mapping the reinforcement, what is necessary for calculation of the cracks. So thanks to complete refactoring of the new reinforcement ratio calculation, where the reinforcement itself was mapped into the model, the calculation speed was increased by 30%. And these differences are noticeable for elements that are very strongly reinforced with the wire fabrics. So you're getting more time on the other things, because we are saving your times during the calculation. The other improvement is connected also with the speed of the calculation. So in the previous versions, the circular openings were locally remeshed with the triangle elements, and it led to a longer meshing and calculation. It was the version 20.1. You can see there are local remeshing around the opening. And in the current version, 21.1, the mesh around the opening has been simplified in combination with triangle and the quad elements. So verification was also performed on the testing projects, and the speed was increased by 50% on average. But you are getting absolutely same results as in the version 20.1. So you are more efficient, and you are saving the time during the calculation. Right now we will be focusing on the design of the Slender Columns in the application Ideostatica member. So with the greater demands on the subtle structures, engineers are forced to go to the limits of material strength, and especially the limits of the stability. So Ideostatica member provides a solution for subtle compressed columns. The geometry can be created in the member itself, or it can import it directly from the finite element software through the checkbot. The ability to enter any static force load gives the engineer the spread spectrum of the design situation. So at first, I would like to mention the process. So you will get a geometry, you will get the loads, and now it's time for the analysis. So there are 3 steps in the analysis. First, the material nonlinear analysis is calculated, and then you're getting a stress and strain. After that is running linear backlink analysis to getting eigenmodes and critical and eigenmodes, and also you're obtaining the critical factors for a critical load, which tell us how stable the structure is. After specifying the imperfections, either according to a standard or from the experience, you're getting an imperfect model, which will be calculated with geometrical and material nonlinear analysis with the imperfection. Thanks to this solution, the assessment are already only at the level of the stresses and strains, where we make sure not to be exceed the design stresses either in the concrete or in the reinforcement. Of course, as a standard, a clear report not to be missed. And final improvements for version 21.1. This, let's say, issue was resonating on the help desk very often. So we made improvements for fixing that. In the previous versions, I'm meaning older version than 21.1. In the previous versions, the calculation of cracks was according to the standard Eurocode approach, where for minimal effective tensile area of the concrete was used the condition with 3 variables. And the goal was to find out the minimum of them. But for the cross sections with a larger cover, the tensile reinforcement wasn't in the effective tensile area of the concrete, and it led to a 0 utilization in the code check for crack width. In the current version 21.1, if the tensile reinforcement is not found in the effective tensile area of the concrete, the crucial equation from minimum condition is neglected. It has an impact on the increasing area of the tensile concrete zone, and the tensile reinforcement is already inside and calculated. So you're getting more design options, mainly for piers and foundations, where a big, large, or large cover can be found. And now let's go to the first demo, and it will be pre-stressing in the detail. So we run Ideostatica detail and create a new project. In the new project, you can see there is a settings of the code, concrete grade from the library, but also the new feature pre-stressing, where is the material library of the tendons, where you can find big amount of the tendons which are inside. So I select this one and select the concrete cover, global cover. I can select from the templates if I want, but I would like to use the import from the DXF. So I use a general import. So I'm in the application and I would like to import the structure from the DXF. It will be simply supported beam. You can see this is my desired geometry. So I create a geometry, 10-meter span, the thickness is 0.35. It will be a rectangular section. And I have to define the boundary condition in the form of the point distributed supports, which are related to the bottom edge of the beam. So I will place it with the edges. It's located to edge number 3 at the beginning, and I only copy that and put it to the end. So I'm finished with the geometry, and I can proceed to the load definition. You can see at first the first load case is permanent, so I set the uniform load, which will be related on the top edge. The second load case will be variable, which has also uniform load 10 kilonewton per meter on the top edge. And now the third load case, the feature load case, it's a new feature, prestressing. So if you want to do the design of the prestressing, you have to set it and create two combinations. One will be for a short-term effect, and the second will be for the short-term, for long-term effect. The load case for prestressing is empty because the anchoring stress will be put it in the reinforcement. So load cases will be turned off, and I can proceed to the combination rule. You can see we support ultimate limit states only right now. So I set the partial factors 1.35, 1.5 for variable, and 1 for short-term effect for tendon, and 0.85 for load case 3 for tendon due to long-term effect. Now I can proceed to the reinforcement and set the tendon. You can see if I run the plus button, I can use a prestressing tendon template. If I use it, so I can put it according. I can use post tension or pre-tension, and I can set it manually here with the master point and the insert point as the normal reinforcement. But I would like to import the tendon because it's let's say some curve of higher degree, so I can import it. You can see the anchoring stress is 1000 megapascal. And what I have to do, I have to set the number of strands in the tendon. The tendon is in the gray color. I use 10 strands in the tendon. You can see the area was getting increased. This is the anchoring area. And at the beginning and at the end, I will turn on the partially loaded areas because there is a really higher stress there, and I can consider there some confinement effect and increasing of the strength. So I can do that right like this. I only create some reinforcement rebars, some longitudinal rebars, and also the shear reinforcement, the stirrups. And yeah, we are finished, and we can proceed to the code check. In the code check, I will run it, and I'm getting very quickly the results. You can see this is some summary overview of our results. There is completely new entity tendon with the utilization. Now is 69%, and I can proceed to the strength, where you can see there is some local compressive strength under the tendon, 17.6 megapascals, and the tendon is under compression. You can see that on the color bar. Now I can proceed to the tendon, and you can check the stress in the tendon, strain, and the ratio between stress and limit stress, and stress and the limit strain, and the maximal coordinates of the stresses. yeah, if I want to see the long-term effect, I can go to the ribbon, and now I can select long-term effect on the tendon, and also there is a displaying of the stress on the tendon, strain on the tendon, and also I can see the deformed shape for the short-term and the long-term effect. But I have to create the correct combination, not for ultimate limit state, but for service arbiter limit state. Now you can see the diagram. This is a diagram with the hardening, linear diagram, and the report. The report can be, as you know, exported to docs file or PDF. Here is a tendon. Here is a material diagram for tendon, loads in the form of the load cases and the combinations, some reinforcement, scheme of the reinforcement, and the tendons from the point of view of the anchoring, stress at the beginning and at the end of the tendon. And I can see the results. I would like to focus on the tendon. Here you can see the displaying of the results on the tendons in the beam, and everything is tabulated in the and the final explanation. Let's proceed to the second demo. The second demo will be focused on the beam link between sub 2000 and the code checking of the Slender column in this application Ideostatica member. So let's go in. You can see this is the frame structure in this sub 2000, and I would like to do the code check of the Slender column. So I use the export and select the concrete and create completely new project. Create a member. Now will pop up the analyzed member and the related member. The analyzed member is the column which has been selected, and the related members are the other ones. So I can go to the load configurator, where I can see load cases and the combinations. I have created only one combination for ultimate limit state, so all the other one can be removed very quickly with the right button and delete. You can see this is my prescription and linear evaluation of the combination. It's not a black box. It's not a black box. I can do the code check of the check of the combinations from the point of view of the internal forces. I can check it with the sub 2000. You can see same value for normal force for combination. Now I can proceed to Ideostatica member, and we will see the analyzed member is in the solid form. Related members are in the wireframe modes. So I have to change the type from the beam to column. Related members, there is very important to set correctly the boundary conditions. I have to release the motion in the X direction, and all the rotations will be fixed because it's a frame model, and all the other related members will be fixed. All rotations and all translations. The combinations from the internal forces has been derived the loads, and for analyzed member has to be also correctly set the support, which will be fixed in all directions. Now I create reinforcement. The reinforcement is very easily to do. You will go to reinforcement dialog. You can see this is the same interface as for RCS. There is some parametric templates and very quick design. You can see on the one click. And what I will see the same rendering of the reinforcement as in the detail. It's very nice and smooth way how to control it. And right now we can continue to do a linear calculation. We will get the results for shear, torsion, capacity for ultimate limit states. And yeah, this is the traffic light. You can see it's green, So the utilization is between 60 and 95%. If I want to see more detailed results, I can go through the RCS and see what is happening on the cross section. This is the first stage, but you know, the column is really slender. So I would like to use some more advanced analysis. So at first I will run material nonlinear analysis to get the stress and strain on the rebars and also on the concrete. And I would like to see some more detailed results. The detailed results are displayed on this fiber, on this plate, where you can see the stress and the strain and also the utilization of the stress and the strain. Now it's time to run linear backlink analysis to get the eigenmodes and eigenshapes with the critical factor. You can see the first critical factor and the eigenmode is 18. I have to put there the imperfection from the experiment or from the code. It's published in the code, and I'm getting imperfect model and run geometric and material nonlinear analysis with the imperfection and getting the stress and strain also on the column. You can see we are neglecting the stress in the tension in the concrete. All tensile forces or tensile stresses are transferred through the rebars. Strain, you can see the strain check. Yeah, we are under 60%. So it's in the gray, and I would like to see reinforcement, stress in the reinforcement. The red color is under compression, blue color is under tension. If I want to see more, I can go to the report and see the detailed report with the geometry, cross sections, material nonlinear analysis, and the results in the form of the traffic lights, also linear backlink analysis, and final geometrical and material nonlinear analysis with the imperfection with the tableized values. So I think, Martin, now it's up to you to sum it up, please.
Yeah, thank you, Lukáš. So just once again, just remember what have we seen. The new version of Ideostatica brings more design options. As we see, we can design pre-stressing details in Ideostatica detail, and we can also solve stability issues. That's also design option of because we can design slender columns in Ideostatica member. We have also speed up the calculation speed by some improvement in solver. And thanks to connection to Checkbot, we can also be more productive with our in our workflow during the transfer of the data and the models from the external applications. So thank you, Lukáš. And now I would like to ask Ralph what is coming in steel in new version.
Thank you again, Martin. And let's set up the sharing properly. And hopefully we can all see my screen again.
Yes.
Lovely.
Okay.
So now it's time to go through what is new in steel for 21.1. And really excited to be showing this to you today. And first of all, we are moving the connection browser out of beta. It might have seen that it's got a brand new name as well. We are now calling this feature Connection Browser, and it helps find suitable solutions based on the geometry of the members that you have within your design. Currently, these design sets are limited to the ones that we provide for you, or your own private store. Over the next few releases, these design sets will extend and allow you to create and manage a company library. It also has a method to create what might be termed non-standard connections by using a built-up connection using standard templates that are within these design sets. So a non-standard connection very quickly becomes a standard connection for your particular situation, for your particular company. And again, this is designed to improve the initial speed at which when you start a connection, and it will certainly help new users of Ideostatica to boost their connection design. The Ideostatica material database has been appended by more European sections according to specific product sheets. Putting my UK hat on here, this is going to be extremely useful for the UK engineers, where the National Annex, the UK National Annex, refers to these product sheets. We're also maintaining the thickness-related steel strengths that are built into Eurocodes and the annexes. And again, this keeps us up to date with current Eurocode strategy. There have been some improvements with welds, bolts, and buckling modes in connection to provide clarity, conformity, and to simplify input. With buckling modes, we've increased the number of modes to 30. Sometimes 6 wasn't enough for the checking of complex members or class 4 cross sections. So this new version brings the possibility to increase this up to 30, but the default still remains at 6, and this applies to both connection and member. For 21.1 onwards, the weld strength is taken from the parent steel for the European code and the Indian code, and it's taken from the electrode for all other codes. So this again makes it code compliant, and it's a safe approach. For the bolt parameters, we've removed the pure bearing type option for shear force transfer, as this was obsolete, and it provided sort of like a bit of a strange affair where you could get confused. So we've removed that confusion and just limited it to friction or tension shear option. If you've got a previous design that did use this option, then it would be transferred to the bearing tension shear option. And finally, let me just mention some improvements to Ideostatica member. Now, when you define your supports, you will have the option of using a local or global system to define. And again, this helps very quickly to make those, get those supports correct and aligned to either the member or the global coordinate system. And there is now also a displacement vector sum view, or let's call it the true deflection, when interpreting results, again bringing extra clarity to your designs. And we're now going to have a quick look at what the checkbot and browser look like in Ideostatica connection. For this demonstration, we're going to use SAP 2000, and I'll admit straight away that I'm not a SAP 2000 user, but if we can use, or if I can use Checkbot with SAP 2000, which is outside of my comfort zone, it will prove the case for a standard approach with Checkbot. So first of all, we load the add-in from the SAP 2000 menu, and we are going to import the connections straight from SAP 2000. As you can see in Checkbot, we have all of the members pulled in. So the first thing that we need to do is merge the separate members that have been identified and used within SAP 2000. We can check the loads, and again we see that we've got lots of load cases, but only 3 ultimate limit state combinations. As you can see in the left-hand panel there, we can see some cogs. This indicates that we have a connection, but nothing's been done to it, or not enough has been done to it yet. Choosing a connection and the draw option, we can actually pull in and visualize the results that we've obtained from SAP 2000 as well. And again, we've got options for different display, solid, transparent, or wireframe. If we open one of these connections, we will see the members and the loads that are applied to those members. So as you can see here, we've got a member framing in to a main beam. And when we use the propose options, we had various options for at choice of connection. And very quickly, we can build up a connection based on these proposals and run a check. And as you can see, 98% is a fairly well used connection. And now reverting back to Checkbot, you will see that we have a green tick, which means that we've now input enough information to the connection and it's passed the code check. Moving on to the column connection, we're going to see an example here of a non-standard type of connection. Now this, to many people, would be a standard connection, but we build our connections up one by one. So when we use the propose option, you'll see that we don't have anything. But if we use the selection method, we can build up a beam framing into the column flange, and then we can add in the beam into the column web. As you can see here, there are operations that we don't really need, and we can either turn them off, make the right choice, or delete them. Now I'm going to be doing some tidying up after, and you'll see how we can do that. So this time, what we want to do is we want to propose the second connection. And as you can see, it's picking up lots of options from the library of templates that we have supplied with Ideostatica connection. And if we just pull one of those in and assign some bolts, as we do normally, you'll see that we've got a notch that has come through, and we can certainly improve that option by removing it. And we have a thin plate connection, which we can then amend the forces location and run the calculate. And as you can see, this is a very safe connection, shall we say. Now the question is, what happens once things change? Where do you go back to? Well, you should always go back to the originating model, because this is what is generally referred to as the single source of truth. So if the design starts in SAP 2000, we go back to SAP 2000 to make the changes. And here I'm showing my ignorance of SAP 2000 and eventually picking a different size of beam without any arbitrary cores, and we're running the analysis again. Starting the plugin, we are going to synchronize the changes that we've made to this model back into Ideostatica. And apologies for the lag in the add-in dialog box. When we synchronize back, we'll see that that cross-section has changed from an IPE 220 to an IPE 180, and the connections that we need to run again. We can choose to run these connections straight from Checkbot, and as you can see here, we've got one that is passed code and one that has failed code, which is quite good because now we can actually go into this connection and look at why it's failed. And I've got a sneaking suspicion it's got something to do with the size of the beam and the fin plate and bolt distances. Because what we're going to do is we're going to just tidy up the connection a little bit and then look at that connection. We've run a pre-design on it to make it a little bit safer, and we're seeing now that it's passed. And what this means is that we can use Checkbot not only as the method to pull in data from finite element and BIM solutions, but we can also use it to manage the connections that we do within the project. So it becomes the start of a connection managing tool for use within the model and Ideostatica connection. And that concludes the demonstration for steel.
Thank you, Ralph. Very nice demo. And I would like to also again sum up what we have seen. I really like this combination of Checkbot and connection browser. So as we saw, we can really be efficient and really speed up the design of connections using or reusing, in fact, existing connection designs from the library of connection browser. And we can also be very effective once we use a Checkbot for the synchronization and the management of changes between our projects. Okay, so once again, thank you. And now let's move on to another topic, and that are the obsolete applications. And I will take a presenter and let me just share the screen. Okay. And as you see, we put all development power into our main applications, into Ideostatica connection, detail, member, Checkbot, and the new improvements like this. And it was not easy to make this decision, but I feel it's important to be fair to our users and say that we will not improve and maintain these obsolete applications. So as you see, we in fact are stopped the development of a general cross-section application of slab, corbel, frame, column. And so let's say the steel beam, that means that that's the standard checks based on the formulas in Ideostatica beam, and also steel designer, that was also quite old application, especially for the BIM links we used in past for the link with Axis, VM, and applications like this, and it was also used mainly for the checks based on the standard formulas of the code. But we still, or you can still use them, because all these applications are available in the latest page of the version 21. It's the page 21.04. So if you would like to continue in these applications, you can still keep this version on your computer and use them. They will not be in the version 21.1 and also in the next versions of Ideostatica. And finally, let me also mention some another coming events. So we can look forward to Ideostatica Excellent Award. You can find all info on our website. So if you go to ideostatica.com and in the menu to company and then find the Ideostatica Award, so you can see that we have started this year a user contest for structural engineers, for the professionals and also for young talents, for students. So if you are interested, and we will be very happy that you can register your own project. Here we can see some important deadlines. So in fact, we have still some time for the uploading of the project, and the announcement, as you see, of the winners will be on November 24th. And as I mentioned, there are two categories. One is for just, let's say, professional projects, and we have also the category for the students. Yeah, here are also important to mention some prices, and we can also see already uploaded projects in the gallery, so you can see that, or can investigate. Or there is also, of course, more already the projects which are already here in our gallery. So that's Ideostatica Excellent Award, and I would also again let's go back to the PowerPoint. Sorry, hopefully, yeah. And I would also like to invite you to Ideostatica User Day. Of course, we will send you a special invitation, but for now, you can keep, or let's say, save a date of November 24th. So put it into your calendars, and it will be an again also online event, the whole day event, and we will show you and we can discuss also a lot of topics related to Ideostatica. So that's in fact that's it. That's all what we wanted to tell you today. Before we close this webinar, let's also check the questions coming from you. And so let me open the queue of the questions. First, I would ask, there was a question about the limitation of exported connections and members from or by Checkbot. So maybe Ralph can tell us more about this, and I will between check also the others.
Yes, thanks, Martin. So Checkbot will import practically or virtually all of your members, but we advise not to do too many at any one time, because you'll be limited by the amount of processing power that your PC or laptop actually has. So it's best to do these in batches of 10, 12, whatever, and build up the model directly. The only caveat with that is if you import a SAF file from the new Nemetschek format, in which case the whole of the SAF file will be imported into Checkbot, which actually means you'll get the whole frame and all of the connections directly from the SAF file.
Okay, thank you. Then there was quite a lot of questions about another softwares or the BIM links, and there was questions about the Strand 7, the Sophistic I see, and Reno. So let's say the general answer to all of these requirements for another BIM links is that, of course, we keep some important softwares in our backlog and we add more and more BIM links. On the other hand, that was also another motivation for our new checkbot, because it's now open to everybody. So if another also external developers, external parties can use our open interface, IOM, and link their software to checkbot and use the same workflow which we saw during today's presentations. So, and that's next. And then I see the question about the Austrian concrete code. So I would ask Lukáš if
Yes,
there is a possibility to add this code to our applications.
I think it depends on the discussion with the product development engineers. It's for longer discussion, but
Yeah.
we will take it into account to the wish list and talk about it.
Yeah. As I know that's in our long-term backlog, but just to be fair, that I know that it's not in our plan for a next version. And another question from Concrete and the detail, it's about the SLS checks for pre-stressed members in detail.
Yeah. So actually, right now there is a possible to do the code check only for ultimate limit states, but we are preparing service limit state to the details, so you can looking forward to update in the upcoming versions.
Okay, and I see again a lot quite questions from your demos. Another user is asking if we can, or whether we calculate the eigen or the eigenvalues for the frequencies imported from the sub 2000 if we take into the account the boundary conditions of the analyzed members.
Yeah, so you know the principle or how it works. So you model, you are doing a global model with the springs, soil, or whatever you want, and you run the analysis and you're getting the internal forces. After that, you select the critical member, export it through the checkbot, and you can see you could also display the internal forces. If you are going from the checkbot to member, we are deriving the internal forces to the loads, and after that you can define the boundary conditions, no springs, the boundary conditions with the relevant internal forces or what relevant loads, which is derived from the internal forces from your finite element software, with where there are considered the springs and some nonlinearity and so on. And you run material nonlinear analysis. After that, you get you run a linear backlink analysis, and after that you run geometrical and material nonlinear analysis with the imperfection. So this is the process how it works, and yeah, that's it.
Okay, thank you. Then I see the questions, a question about the TECLA structure designer, because as we saw in a table of current applications, that the TECLA structure designer is not supported by a checkbot now. So Ralph, do you know something about our plans?
Yeah, it's been on the roadmap for a while, and we've had recent meetings to cement the relationship with TECLA Structural Designer as well, or TECLA full stop. So what I would say is watch this space, and we'll let you know what's happening on that point very, very quickly.
Yeah, as I know, it's already in the process, so I hope it will be available soon. Okay, and I see also some questions, some doubts about the version of whether user can use at the same time version 21.1 and 20. Yeah, that's possible. In fact, each, let's say we call it main version, is installed as a separate application. So you can keep on your machine versions, for example, 20 and then 20.1, and it's the same with the 21.0 and 21.1. So you can keep all of them, but of course keep in mind that once you open, for example, your project or create your project in version 21, you will not be able to open it in the version 20. Yeah, so you cannot open that in older versions. Okay, so I think that's it. That's the most, that is the list of questions, or the most general questions. So thank you very much for your attention, and we are looking forward to see you in some of our next webinars. Enjoy the rest of the day, and goodbye.
Bye-bye.
Goodbye from me.